Fire is a powerful force. It can be life-saving or life-threatening depending on how we handle it. But did you know that not all fires are the same? Different types of fires require different methods of extinguishing, and using the wrong approach can make things worse. In this video, we'll break down the classification of fire, explain each type, and discuss the best ways to combat them. Stay tuned. This knowledge could be a lifesaver. Before diving into fire classification, let's quickly recap how fire works. Fire is a chemical reaction that requires four key elements: heat, fuel, oxygen, and an uninterrupted chemical chain reaction. This is known as the fire tetrahedron. Remove any one of these and the fire goes out. Now, depending on the fuel source, fires are categorized into different classes. Let's explore them. Now, we will talk about Class A fires. These involve ordinary combustible materials like wood, paper, cloth, and most plastics. These are the most common fires you might encounter in homes or forests. To put them out, you can use water, foam, or ABC dry chemical extinguishers, as these methods cool the flames and remove heat from the fire tetrahedron. Next up, Class B fires. These involve flammable liquids and gases. Think gasoline, oil, paint, or propane. Water won't work here. In fact, it can spread the fire. Instead, you need foam, CO2, or dry chemical extinguishers which smother the flames by cutting off oxygen. Remember, never use water on a grease fire in the kitchen. That's a Class B hazard. Moving on to Class C fires. These are electrical fires caused by faulty wiring, overloaded circuits, or malfunctioning appliances. Since water conducts electricity, using it here could lead to electrocution. Instead, use CO2 or dry chemical extinguishers, which are non-conductive. Always cut the power source first if it's safe to do so. Now, let's discuss Class D fires. These are rare but extremely dangerous. They involve combustible metals like magnesium, titanium, or potassium. These metals burn at extremely high temperatures, and ordinary extinguishers won't work. Instead, specialized dry powder extinguishers are needed to smother the flames without reacting with the metal. Finally, we have Class K fires. These are specific to commercial kitchens and involve cooking oils and fats. If a pan of oil catches fire, water will cause a violent explosion. Instead, use a wet chemical extinguisher designed for kitchens, which cools the flames and creates a barrier to prevent reignition. A fire blanket can also help smother small grease fires. Before we wrap up, here are some crucial safety tips. Always use the right extinguisher. Remember the pass method? Pull the pin, aim at the base, squeeze the handle, and sweep side to side. Store flammable materials safely and have an emergency plan with clear exits, working smoke alarms, and a designated meeting point. Prevention is always better than reaction. Understanding fire classification can make all the difference in an emergency. Now you know how to identify different fires and the best ways to extinguish them. Fire emergencies can happen anytime, anywhere, and knowing how to use the right fire extinguisher could mean the difference between a small incident and a full-blown disaster. But did you know there are different types of fire extinguishers for different kinds of fires? In this video, we'll break down the main types, their uses, and how to identify them so you're always prepared. Let's get started. Before we dive into extinguishers, let's quickly talk about fire classes. Fires are categorized based on what's burning, and each type requires a different approach. Class A fires involve everyday materials like wood, paper, and cloth, things you'd find in a typical house fire. Then we have Class B, which covers flammable liquids like gasoline, oil, or paint. These fires spread fast and can be extremely dangerous. Class C fires involve electrical equipment, think wiring, appliances, or fuse boxes. Water is a big no here because it conducts electricity. Next, Class D fires are rare but intense. They involve combustible metals like magnesium or sodium, often found in industrial settings. Finally, Class K fires are specific to kitchens where cooking oils and fats can ignite. Knowing these classes is key because each extinguisher is designed for specific fire types. Using the wrong one can be disastrous. Let's start with the most basic type, the water extinguisher. You'll recognize it by its solid red label. This extinguisher works by cooling the fire, making it perfect for Class A fires, things like wood, paper, or cloth. Picture a campfire getting out of control. This would be the right tool. But here's the critical part. Never use it on electrical fires or flammable liquids. Why? Because water conducts electricity, so you could get electrocuted. And if you spray water on a gasoline fire, it will spread the flames instead of putting them out. Also, avoid using it on metal fires. It won't work and could even cause a violent reaction. So, remember, water extinguishers are great for ordinary fires, but that's it. Next, we have foam extinguishers, marked by their cream colored label. These are a step up from water extinguishers because they can handle both Class A and Class B fires, meaning they work on ordinary materials and flammable liquids like petrol or paint. The foam smothers the fire, cutting off its oxygen supply while also cooling the fuel. This makes it great for things like a fuel spill fire in a garage. But here's the catch: foam is still mostly water based, so don't use it on electrical fires. And while it might seem like it could work on a kitchen fire, it's not designed for cooking oils. That's what wet chemical extinguishers are for. So foam is versatile but still has its limits. Now, let's talk about CO2 extinguishers, the ones with the black label. These are a favorite for offices and labs because they are perfect for electrical fires. Unlike water or foam, CO2 doesn't conduct electricity, making it safe for things like computers, wiring, or machinery. It works by displacing oxygen, effectively suffocating the fire. Another big plus, it leaves no residue, so there's no messy cleanup. But here's the downside: it's not great for ordinary fires like wood or paper. Why? Because while it removes oxygen, it doesn't cool the material enough, meaning the fire could reignite once the CO2 dissipates. So remember, black label for electrical and liquid fires only. If you need a one size fits most extinguisher, the dry powder type, marked with a blue label, is your best bet. This is the most versatile extinguisher because it works on Class A, B, C, and even metal fires, Class D. It uses a chemical powder that interrupts the fire's chemical reaction, making it super effective. Imagine a workshop with different fire risks. This extinguisher could handle almost all of them. But there's a big warning: don't use it in small, enclosed spaces. The powder creates a thick cloud that reduces visibility and can be dangerous to breathe in. Also, it makes a huge mess, so it's not ideal for homes or offices unless absolutely necessary. But for industrial settings, it's a lifesaver. Finally, we have the wet chemical extinguisher, recognizable by its bright yellow label. This one is specialized for Class K fires, meaning kitchen fires involving cooking oils and fats. If you've ever seen a deep fryer catch fire, this is the extinguisher you'd want. It works in two ways. First, it cools the burning oil, and second, it creates a soap-like barrier that prevents reignition. But here's the key: never use it on anything else. It's not designed for electrical fires, liquids, or ordinary combustibles. So, unless you're dealing with a kitchen fire, leave this one in its designated spot. Now that you know the types, here's how to use one effectively. Remember the pass method. Pull the pin, aim at the base of the fire, squeeze the handle, and sweep from side to side. And always ensure you have a clear escape route. Safety first. So there you have it, the essential guide to fire extinguishers. Let's do a quick recap. For ordinary fires like wood or paper, use water or foam. For flammable liquids, foam or CO2. Electrical fires, CO2 or dry powder. Metal fires, only dry powder. And for kitchen fires, wet chemical is your best friend. Always check the label before use, and remember, using the wrong extinguisher can be just as dangerous as the fire itself. Fire, it's one of humanity's most useful tools, but when uncontrolled, it can be devastating. So, how do we stop it? Welcome to today's video, where we break down the methods of fire extinguishment with real-world examples. Whether you're a student, safety professional, or just curious, this guide will equip you with essential knowledge. Let's dive in. Before we can extinguish fires, we need to understand what creates them. Every fire requires three elements, what we call the fire triangle. First, fuel. This could be anything combustible, like wood in a campfire, gasoline in a car, or paper in an office. Second, heat. This is the ignition source, whether it's a spark, an open flame, or even electrical arcing. And third, oxygen, which makes up about 21% of our atmosphere. The key to firefighting? Remove any one of these elements and the fire goes out. Simple in theory, but in practice we've developed specialized methods for each approach. The most visible and commonly understood method is cooling, removing heat from the fire. Picture firefighters battling a house fire. Those powerful streams of water aren't just wetting the building, They are absorbing tremendous amounts of heat energy, bringing temperatures below the point where combustion can continue. In commercial kitchens, you'll find specialized wet chemical extinguishers that both cool the burning oil and create a soapy blanket to prevent reignition. And in high risk industrial facilities, automatic deluge systems can release thousands of gallons per minute to rapidly cool entire areas. But crucially, cooling with water doesn't work on all fires. In fact, using water on electrical or grease fires can be extremely dangerous, which brings us to our next method. When cooling is inappropriate, we turn to smothering, cutting off the fire's oxygen supply. In home kitchens, you've probably seen fire blankets. These non-flammable sheets are perfect for smothering small pan fires by creating an airtight seal. In sensitive environments like server rooms or laboratories, CO2 extinguishers are ideal because they displace oxygen without leaving any damaging residue, and at airports or refineries, you'll find massive foam separation systems that blanket fuel fires with a thick, oxygen-excluding foam layer. The science here is straightforward. No oxygen means the chemical combustion reaction simply can't continue. Sometimes the most effective strategy is to remove the fuel source entirely. We call this starvation. Wildfire fighters are masters of this technique, using bulldozers to create wide containment lines by removing all vegetation, literally starving the advancing flames of fuel. In industrial accidents, the first priority is often shutting off gas or fuel valves to stop the flow of combustible material. Even in simple scenarios like a campfire, we practice starvation when we stop adding wood and let the fire burn out. This method requires anticipation and quick action, but when executed properly, it's incredibly effective. Our most technologically advanced method is chemical inhibition, where we disrupt the actual combustion chain reaction. The ABC dry chemical extinguishers you see in hallways work this way. The powder interferes with the fire's chemistry at a molecular level, effective on multiple fire types. In critical environments like aircraft, you'll find halon systems that accomplish this without residue, though they are being phased out for environmental reasons. And for serious oil and gas fires, Purple Cape powder is the specialist's choice, specifically formulated to knock down intense hydrocarbon fires. This is firefighting at the microscopic level, breaking apart the very reactions that sustain combustion. Now that we understand the methods, let's match them to real-world fire types. Class A fires involve ordinary combustibles like wood or paper. Here, cooling with water or blanketing with sand works perfectly. For Class B, liquid fires like gasoline or oil, we smother with foam or chemically inhibit with dry powder. Electrical fires, Class C, demand non-conductive agents like CO2 that won't conduct electricity back to you. Metal fires Class D require specialized powders that can handle extreme temperatures, and in commercial kitchens, Class K fires from cooking oils need wet chemical extinguishers that cool while creating a soapy seal. Always choose your extinguisher based on this classification. Using the wrong type can be deadly. So now you understand the 4 pillars of firefighting: cooling, smothering, starvation, and chemical inhibition. Each has its place, and using the right method for the specific fire type is absolutely crucial. Remember, fire safety starts with prevention, but knowledge is your best defense when prevention fails. If you found this helpful, smash that like button, share it with someone who might need it, and subscribe for more life-saving knowledge. Stay safe, and I'll see you in the next one.